Hello students, today we'll be working on multiplying polynomials. Before we do that, we're going to do a quick review of multiplying a monomial factor, like I'm circling here, 6ab, by a polynomial factor. So remember, when we do that, we write the monomial 6ab and we multiply that by each term of the polynomial. So first by 3a to the second, then we put a plus sign, we go back to the monomial 6ab and multiply that by the other factor or the other term inside the polynomial. And then remember, you multiply the numbers in front, the coefficients. So 6 times 3, which would give us 18. And then we keep the bases, so we have an a to the first and an a to the second. We'll add those exponents to get a to the third. We also have a b. Then we have plus. We'll multiply 6 times 4, so 24. We have a, and then we have b to the first and another b to the first, so b to the second. And that's our first review problem. Our second review problem is going to have a couple of parts to it. So first we'll take negative 4g and multiply that by distributing. So negative 4g multiplied first of all by negative 2g to the second plus, and then we'll do it again, negative 4g multiplied by 3g, and then plus, then negative 4g, and we'll be multiplying that by negative 7. Now, we have to add to that, so we're going to add, and then we'll be taking negative 3 and distributing it. So negative 3, we'll multiply that by 2g to the third. We'll add, we'll take negative 3, multiply that by negative 5g, add, and then finally take negative 3 and multiply that by 2. All right, so doing that, I'm going to put a line because really all of this is all on one line. We would get 8g to the third and then we will get, for our next one, negative 12g to the second. Then our next one, we will get positive 28g, and that's the top line. Then our next line, remember we're adding all of this, so we have negative 6g to the third. So we can line that up underneath our g to the third term. For these two, we'll have positive 15, but notice that's just g. So I'm going to skip over. And then finally, we'll have plus, and then we have negative. So I'm actually going to change that to minus 6. And again, I'm going to draw a line, only this time I'm going to add. And I haven't given myself very much space, but I'll squeeze it in there. So 8 and negative 6 will add up to 2 g to the third power. We'll have to bring down the minus 12g to the second power. Then we'll add 15 and 28, making 43g. And finally, we'll bring down the minus 6. So your final answer is this one that I've squeezed in here in blue, 2g to the third minus 12g to the second plus 43g to the first, and then minus 6. Okay, so to take this to what we're going to be doing today, we're going to be multiplying polynomials by distributing and follow a very similar pattern to what we did with these examples. Distributing each term of the inside of one polynomial by each term inside the other. And when you're doing this with binomials, this is sometimes referred to as the FOIL method. And FOIL stands for first, and then outside, and then inside, and last. So as just a little bit of a pattern for you, if I took a plus b times c plus d, first would be this first term times this first term. So the a times the c, that would be the first terms. Then the outsides would be the ones on the outsides, the a and the d. And then the next terms would be the insides. That would be the b and the c. And then finally, the last terms, the b and the d, and that's where they get the idea of FOIL. But the big thing to notice is that you take every term of one polynomial by every term of the other polynomial. And when you're finished, if you have like terms, then you add those like terms. So when I'm multiplying binomials, I like to notice that I start off with 1, 2, 3, 4 blanks. And so that's what we're going to work on in our following 3 examples. So in these examples, we'll be multiplying y plus 8 and y plus 4. So I'll be distributing, and I'm going to go ahead and make 4 blanks to be filled in. So I'll be taking y times y, and I'm going to write that down so you can see it. And then I'll be taking y times 4. And then I'll be taking 8 times y and 8 times 4. And so I'm not really going to set it up like FOIL, although that's exactly what I did do. But I think this is a little bit easier for you to see. So y times y, remember that I add those exponents, I get y to the second, plus y times 4, I can just write as 4y, plus 8 times y, I can write as 8y, and then 8 times 4, which gives me 32. And then these two terms can be combined. So I'll write y squared plus, I can add the 8 and the 4, making 12y, and then plus 32. And that is very typically what happens when you are multiplying two binomials. So we'll look at example number 2. We have 2x plus 1 times x minus 6. So 4 blanks to show me that I've got 4 multiplications, starting off with 2x times x. And then I'll be taking 2x times negative 6. Then I'll be multiplying 1 times x. And finally, 1 times negative 6. And notice that sometimes I write a parentheses to show that I'm multiplying. So 2x times x, I'm going to write the 2, keep the x, and add the exponents. So 2x to the second. And then I'm taking a positive 2 times a negative 6. That will be a negative 12x. Then I'll be taking 1 times x. I can write that just as 1x. And then 1 times negative 6, which I can write as negative 6. Again, my middle two terms are like terms. They have the same variables, same exponents. I can combine those. I'm going to bring down 2x to the second, combine to get negative 11x, and then bring down the minus 6. So those are your first two examples. I'll do the third one with two variables. I'm going to clear the screen so that I have space to work on this third one. So on the third one, we have two variables, but the idea is the same. So I'm multiplying two binomials. I'll have 4 blanks to fill in. So starting with 5a times 2a. So sometimes it's easier to show that you're multiplying by putting parentheses there. So 5a times 2a. Then I'll be multiplying 5a times 8b. Then I'll go back and I'll be doing negative 4b times 2a, and then negative 4b times 8b. And so I'll multiply my 5 and 2 together to get 10, and then the a's have exponents of 1, so I'll keep the a and add the exponents to get a to the second power. Plus, now I'm taking 5 times 8, that's 40, and then I have an a times a b, so I'll just have to write that as ab. Now I have a negative 4 times a 2. That's going to be negative 8. And I have a b and an a. I can write that as ab as well, and that helps me see that it's a like term. And then I have a negative 4 times a positive 8. That's negative 32. B to the first times b to the first. I'll keep the b and add the exponents. So I'll have 10a to the second. My middle terms both have ABs. So I can add the numbers 40 and negative 8. That makes positive 32 AB, and then minus 32 B to the second. And I don't have any other like terms, so that would be my final answer. Now we have 3 problems to go on the back side, and those have some special products, as well as multiplying when we have a binomial and a trinomial. So we'll continue on. Number 4, we have what I refer to as conjugates. Conjugates are identical except for the middle signs. So here I have 3n plus 2 and 3n minus 2. Again, these are called conjugates, and I'd like for you to see what happens when you multiply conjugates. So 4 blanks. we'll take 3n times 3n, then 3n times negative 2. Then we'll come back here, we'll take positive 2 times 3n, and positive 2 times negative 2. So our first one, 3n times 3n, that would be 9n to the second. Then we have a positive 3 times a negative 2. That's going to be negative 6, and then there's an n. So negative 6n. And then positive 2 times 3n, that's going to be positive 6n. And then finally we have 2 times negative 2, and that will be negative 4. So I'll have 9n to the second. Now, my middle terms, not only do they combine, but when they do combine, they actually cancel each other out. I have a negative 6n and a positive 6n. So they cancel out. I don't want to write it as 0n. I just want to cancel it. And I'll bring down minus 4. So when you multiply conjugates, which are the same exact binomial except the middle sign, the middle term will cancel out. So that's what happens with conjugates. I'll move on. We'll look at binomial squares. So your next example, binomial squares. Notice that it gives you a hint to write the base twice and multiply. So you have 8g minus 3 to the second power. Your base is 8g minus 3. So we will write it twice, 8g minus 3 times 8g minus 3. And then I'll multiply that as I have been. So with our 4 terms, our 4 blanks, so we'll be taking 8g times 8g. And we'll be taking 8g then times negative 3. Then we'll come back to here. We'll take negative 3 times 8g. And finally, we'll be taking negative 3 times negative 3. So 8 times 8 is 64. And then our g's will multiply by adding the exponents and get g to the second. Here we have a positive 8 times a negative 3. That's going to be negative 24g. We have a negative 3 times a positive 8 again. That's going to be a negative 24g. And finally, we have negative 3 times negative 3, and that's going to be positive 9. So the middle two terms do not cancel. They instead will combine. So 64g to the second minus 48g plus 9. And we have one more to go, and we will finish that one up in just a moment. In our last problem, we're taking a binomial times a trinomial. So we'll follow our same pattern. We're going to take 3a and multiply that by all 3 terms of the trinomial. So that will be 3 blanks that we'll have to fill in. And then we'll be taking 4 times each term of the trinomial. So that will be 3 more blanks that we'll have to fill in. So we'll have a total of 6 multiplications that we're doing. So I'll start with 3a multiplied by a to the second, then 3a multiplied by negative 12a, and I'll be taking 3a and multiplying that by 1. So that would take care of our first set of multiplications. Then we'll switch, and we'll be looking at 4 being multiplied back to the beginning by a to the second, and then 4 being multiplied by negative 12a, and finally 4 being multiplied by the 1. So as we look at our answer, we have 3, and then on our a's, we'll keep the base of a, add our exponents to get a to the third. I'm multiplying a 3 times a negative 12. That will be a negative 36. I have an a to the first and an a to the first. So we'll add the exponents to get a to the second. I have 3a times 1. That would just be 3a plus, and I have 4 times a to the second, which would just be 4a to the second. Next, we're taking 4 times negative 12a. That's negative 48a. And finally, 4 times 1, which is 4. So as you look back at the answer, we want to see, are there like terms? For the 3a to the third, no like terms, so that will drop down in the answer. But negative 36a to the second can combine with positive 4a to the second. So we'll add the numbers, the coefficients. That would be negative 32a to the second. Remember, you keep the variable and its exponent when you're combining. And I also have a positive 3a and a negative 48a. Those are like terms. So 3 and negative 48 would make negative 45, and I'll keep the a. And then finally, my last term, 4. So there you have multiplication. Good luck as you do your homework and continue to ask questions as needed.